In this lesson, we will discuss some different categories of data, and we will explore how to perform some basic plots in R for the various categories. We begin by dividing data into one of two types. Qualitative data classifies individuals into categories. For example, college major, model of car, or gender of one's pets are all qualitative. Quantitative data are numerical and tell how much or how many of something there is. One's height, the age of a house, or the score on an exam are all examples of quantitative data. Qualitative variables can be divided further into ordinal or nominal variables. Ordinal variables have a natural ordering. For example, the sizes of drinks sold at a fast food restaurant are ordinal. Perhaps they are classified into small, medium, large, or extra large. Nominal variables do not have a natural ordering. For example, political affiliation or states of residence are nominal. There is no natural ordering to these. Quantitative variables can be divided into discrete or continuous variables. Discrete variables have values that can be listed. For example, the number of siblings a person has is discrete. You can list the possibilities, like 0, 1, 2, 3, or so on. Another example of a discrete variable is the number of full points taken off an assignment. Continuous variables can't be listed. They must be measured. Height is an example of a continuous variable. All possible heights can't be listed. Height must be measured. Another example of a continuous variable is the amount of charge remaining in a battery. Now let's think about the various plots that are appropriate based on the type of data given. Right now, we'll limit ourselves to plots involved in a single dataset, that is, one variable data. Later, we'll discuss plots involving more than one dataset. We start with qualitative data. Two basic graphs used to display qualitative data are bar plots and pie charts. A bar plot uses rectangular bars of varying heights to compare categories along the x-axis, with the height of each bar corresponding to the data value it represents. A pie chart is a circular graph that shows the proportions of different categories in the dataset. The size of each slice corresponds to that category's proportion. Okay, let's jump into R and see how to create bar plots and pie charts, along with some of the options that are available for customizing these graphs. We need to start with some data. From the Stockholm International Peace Research Institute, I've compiled some data about which countries were the largest exporters of weapons. Let's import this data set and take a quick look at it. Note the name of the variables, country and exports. We'll start with a bar plot. Here we use the bar plot command in R. The variable we use here is exports from the weapons dataset. Now we can add the category names with the names.arg option. Here we will set the names to the country variable. We can add a main graph title with the main option. We'll call the title Weapons Exports by Country. We can add a color with the COL option. It's easy to find R colors by name using a simple Google search. Here I'll set the color of the bars to Dodger Blue. Be sure to put parentheses around the color name. As you can see, we've got a pretty decent looking graph so far. But just for fun, let's get a little fancier with the colors. I'm going to install a package called rColorBrewer. This package provides a number of predefined color palettes. You only have to install the package once, but each time you want to use it, you'll have to call it using the library command. The display.brewer.all command will show all available color palettes. Let's use 5 of the colors from the Pastel 1 palette. To do so, we'll set the COL option equal to brewer.pal, where n equals 5 and the name is Pastel 1. Congratulations! You've got a nice looking graph that would be suitable to be copied into any report or presentation. Now let's move on to pie charts. To create a pie chart, we use the pie command. We can add the labels with the labels option. Here we'll set the labels equal to the country variable. Similar to what we did before, let's add a main title and apply a color palette. Okay, so we've seen that for qualitative data we can construct bar plots or pie charts. Let's move on to quantitative data. For the moment, we're going to consider two types of charts, a histogram and a box plot. A histogram contains ranges, or bins, of values on the x-axis and rectangular bars whose heights represent the frequencies that fall within those ranges. A box plot is another useful way of visualizing quantitative data. The box part displays the quartiles and the median. An outlier is a data value that is significantly different from the rest of the dataset. If outliers are present, they will also be indicated on a box plot. Let's import a dataset. From the Inside Airbnb website, I've compiled nightly prices for Airbnb rentals in Boston. I'll import this data and we'll call it Rentals. Let's take a quick look at it. We can see that there are 2,324 data points here. Now we can create a simple histogram of the nightly prices using the hist command. Many of the options that we've already used can be used here. For example, I can title my histogram Nightly Airbnb Prices in Boston. I can use a Brewer color palette to select a color scheme. I can also label the x-axis as nightly price and the y-axis as number of rentals. Note here that the different colors of the bars really don't mean anything, it's just for aesthetic reasons. Now one option that may be useful for histograms is breaks. This option defines the number of breakpoints in the histogram. Let's look at a histogram with 3 breakpoints, and then a histogram with 15 breakpoints. Sometimes you may need to play around with the number of breakpoints to get a good visual of the data distribution. One note of caution though, R may not produce a graph with the exact number of breakpoints you specify. It will try to get close, but it really depends on how well the data can be split into ranges. Suppose that we wanted to construct a box plot for the Airbnb prices. This is done with the boxplot command. The default in R is to present box plots vertically. Personally, I think it's easier to read when the box plot is horizontal though. I'm going to make our box plot a little nicer looking by including a few options. I include the option horizontal equals true to make the box plot horizontal. I'll also include a color option to make it light steel blue. I'm going to include a point character option. Here, PCH equals 16 indicates that we want our points to be solid dots. Now a box plot shows the first and third quartiles as well as the median. It also shows data values that might be considered outliers. In this case, we can see that there are quite a number of outliers. Okay, so that's it for this lesson. Here we talked about some of the different ways of classifying data and looked at some different plots, along with some options available to customize their appearance. In the next lesson, we'll talk about putting it all together in preparation for the first project.